the beta decay or emission, and we said that somehow we are changing the number, the atomic number, without changing the atomic mass. And that may be counterintuitive, because you would say if you're changing the number of protons by making this atomic number 1 unit greater, something should happen to the atomic mass as well, because protons have mass. So how do we explain this? The way to explain it is by thinking that, or realizing what happens to the number of neutrons as well. So the number of protons goes up by 1, but that proton must come from somewhere. And that proton comes from the reaction, if you will, of a neutron. So 1 neutron in the nucleus is converted into 1 proton and 1 electron. And again, you see the number of the sum of the atomic masses on the left and the right are the same. 1 on the left, 1 plus 0, 1 on the right. And the atomic numbers are the same on the left and the right. 0 and 1, minus 1, 0. And this explains how we keep the mass constant despite the fact that we are changing the atomic number. So by the reaction of this 1 neutron, the atomic mass would decrease by 1 unit, but we're forming 1 proton, so the atomic mass would increase by a unit, and they sort of cancel out. And then we have the electron that has no mass, so it has no effect on Z or A. Okay, so when we think of beta emission, we think of a neutron producing 1 proton and 1 electron. And that helps us better understand the concept. The positron emission would produce the antiparticle of the electron, which looks just like the electron, only that it has that positive atomic number. Again, the atomic masses remain the same, 30 on the left, 30 on the right. And the atomic numbers remain the same, 15 on the left, 14 plus 1, 15 on the right. How does this happen? How is a positron emitted? It occurs when 1 proton is converted into 1 neutron and 1 positron. What are the implications of that? We would have 1 fewer proton. That means the atomic mass decreases by 1, but we form 1 neutron, so the atomic mass increases by 1, and they cancel out. And that's why the mass number stays the same. The atomic number, on the other hand, if we react 1 proton, the atomic number is going to go down by 1. And there's nothing counteracting that on the right. So atomic number goes from 15 to 14. And of course, to balance the equation, we have a plus 1 for the positron. And that's how we explain where that positron is coming from. It's a reaction of 1 proton forming 1 neutron and 1 positron. And this is just a reminder that for a nuclear reaction to be balanced, the atomic numbers and the atomic masses on the left and on the right, the sum of them all should be equal on the left and on the right. This column here is the neutron to proton ratio. So you can look at what happens to that ratio and associate that with the type of transformation. The one that we did not discuss is the gamma emission or decay. The gamma decay occurs when we have an excited nuclide, when we have an isotope that has absorbed energy and then releases that energy. So it's just the release of energy, nothing more than that. Beyond that happens to the nuclide. There's no change in atomic number, no change in atomic mass. It's just the release of that energy in the form of light, a photon, that is emitted. And then we have electron capture. Let's see if we've got it on the next slide. No. Electron capture, which occurs when one of the inner electrons of an atom is absorbed by the nucleus. That one electron reacts with a proton, and we see that in the changes in the atomic number here goes, for this specific example, goes from 44 to 43. That is because one of the protons in the nucleus reacted with that one electron, inner electron of the atom that's been absorbed. And when they come together, they create a neutron. So the atomic mass would go down by 1 because we lose one proton, but it goes up by 1 because we gain one neutron, and that's why it remains the same before and after. In this case, 92, 92. Okay, that's electron capture. And here what we have is what I call stop and practice, which you will find in most, if not all, of the videos. And the idea is that it will stop the video, or I will stop talking, and you will practice some of what we've learned so far. Do not skip this exercise. It doesn't make any sense if you just watch the videos. Besides, they're boring and you don't practice. So, for instance, here we have, you're going to write the nuclear equation for a number of decays. And I give you here one example. So we complete this equation, and to do that we would need thorium-234-90. We have 4 more here, and here we have, as a reminder, the different types of decays. This is the same, different way to ask the same question. You have to complete the equation. Now you have to, in some cases, give the original nuclide. A couple of questions that use the stability plot. You will find different versions of this plot in different textbooks. And please complete this practice, because it will help you assess whether you are understanding the material, whether I'm explaining the material good enough. Okay, so we're gonna stop this video here.